Kia ora Year 12. This video is the first one I'm making on algebra application problems. This goes with Walker pages 74 to 75. I'm just going to do 2 examples to show you how to start, and I've also put full worked solutions to those questions on Google Classroom. So these questions are not straight out of the Walker book, but they're quite similar. One is about a rectangle and one's about a triangle. At the end, I'm going to give you a strategy for how to solve applications problems. Now, if you're watching this and you're struggling with the achieved skills, you're probably better putting your time into those first and then coming back to this video. Okay, so here's the first one. A rectangle's got 4 sides, obviously. The top and bottom sides of a rectangle are 6 centimetres longer than the other sides. And the area of the rectangle is 315 centimetres squared. And we're asked to find the lengths of these sides. So the first thing that I'm going to do is to draw a rectangle, except in my case I'm just going to do it like that. That was nice. And then I'm going to label some things. So we're told that the top and bottom sides are 6 centimetres longer than the other sides. So what I'll start by doing is labeling one of them as x. And you can either write let x be the short side, or you can just draw it on. So here's x. And we know that the top and bottom sides are 6 centimetres longer. So that side there is x plus 6, and so is this one down here. We know that the area of the rectangle is 315 centimetres squared. So the area of a rectangle is the base times the height. Now we're going to substitute in our values or our variables. So our area is going to be x times x plus 6, and we know that that area is 315. Okay, so this is the equation that I want to solve. And you can see we've got a very simple quadratic. So x squared plus 6x equals 315. We always want to have our quadratic equaling 0. So it's going to be x squared plus 6x minus 315 equals 0. Now at this point what you do is going to depend on what kind of equation you've got. You've got a few options. It might factorise easily, or you could do the quadratic formula or grouping if you need to, or you could put it into your calculator. But I think it's good to show some working here. So in this case, I'm going to do this one with factorization, just to give us a bit more practice at that. And I want to do that so that I show you how to factorize when you've got quite a big constant term here. So we've got to look for 2 numbers that have got a gap of 6 and multiply to 315. Right, so here's 315. I'm going to do a little factor tree, and I'm just going to look for what 2 factors it might be. Oops, I'll just turn that ink to shape thing off. Right, so what goes into 315? Well, 5's the most obvious thing. So I've got 5 and 63. So what I'm trying to do here is I'm finding the prime factors of 315, and from there I'm going to work back to get the factors. So we've got 5 here, 5's a prime. And then 63, well, different things I could do here, but I'm just going to say that that's equal to 21 times 3. So now if I look at the factors that I've got, I don't have to keep going because I'm looking for 2 that have got a gap of 6 and multiply to give me negative 315. And it looks to me like I've found them because the 5 and the 3 together give me a factor of 15, and I've got 21. The difference in those is 6. So this is an example where I started with an applications problem, and it's come out pretty easily with an equation that's going to factorise. So that's going to be my next step. We'll have x plus 21 times x minus 15 is equal to 0. So x is equal to negative 21 or 15, but we must have x greater than 0 because it's a length. So the short side is 15 centimetres and the long side is going to be that plus 6, which is 21 centimetres. Okay, so let's look at what we did here, because these steps are going to work in each case. Well, the first thing I did is that I drew a diagram and I labelled some sides, and I chose one side to be x. Okay, so this is my strategy for these. Diagram first, define something as x, and then get all of the other sides in terms of x. Then set up the equation using information. And in this case, that meant that we did x times x plus 6 equals 315. And next we solved that equation, and you'll do that either by factorizing or the quadratic formula. And lastly, we answered the question in context. So always go back and check that we've answered it. Here we had to find the side lengths. And let's just see if that's what we ended up doing. Yep, we did. And we've written it in context here, right? So you'll see that I've got lengths and units here. Okay, on to the next one. This one's about a triangle. So the hypotenuse of a right angled triangle is 16 centimeters longer than the length of the shortest side. The middle side is 2 centimeters shorter than the hypotenuse. Right, I'm going to start off here by drawing a triangle. Not one like that. Let's see if we can get a nice right angled triangle. Maybe not. Okay, forget about the fancy thing, and we'll just do a triangle by hand. Okay, so here's my triangle. So I know it's a right angled triangle, and the hypotenuse is 16 centimeters longer than the shortest side length. So I'm going to make the shortest side length x, and the hypotenuse is going to be x plus 16. Now the middle side length, which is the last one, is 2 centimeters shorter than the hypotenuse. So if this is x plus 16, this has got to be x plus 14. We're not given the area, but we're just asked to find the side lengths. So the only equation that's going to help me here will be Pythagoras. So we're ready now to set the equation up, and we've got a squared plus b squared equals c squared. So here we've got x squared plus x plus 14 squared is equal to x plus 16 squared. To solve that, we need to expand everything. So we'll have x squared plus, I'm just going to write these out slowly so that we don't make a really common mistake. So remember, these things are what we call perfect squares. This gives me x squared plus x squared plus 28x plus 196 equals x squared plus, here we've got 32x plus 16 16s are 256. It's a quadratic, but it needs cleaning up. So I'm going to bring all of this over to the left-hand side by subtracting this from both sides. So we have 2x squared plus 28x plus 196. I don't know why I'm writing on an angle. I don't think I've ever done that before. I'll try and fix it. Sorry about that. Must be how I've got the computer sitting. Right, let's clean this up. Well, we've got x squared, so 2x squared take away x squared. And then I've got plus 28x minus 32x, so minus 4x. And now plus 196 minus 256 gives me minus 60, I think, yep, equals 0. And again, I've deliberately picked numbers here that are going to factorize, but if they don't, you'd go and do the quadratic formula. So this is a very easy equation to factorize. This is a year 10 one. I've got x here, two numbers that times to give me negative 60, and add to give me negative 4. So it's going to be, let's try 6 and 10. I want to have the big number with the negative, so minus 10 plus 6. So either x equals 10 or x equals 0. X equals negative 6. X is greater than 0 because it's a length. So the sides are x plus 14 and x plus 16. That gives us 10 centimeters, 24 centimeters, and 26 centimeters. So there you go. That's just 2 examples done for you. And remember that this is a good method to make sure you can attack these problems. So what I'd like you to do before you go on with the Walker questions is just to get those notes down into your book and then use the work solutions to help you when you get to some of the trickier ones. Thanks for watching.